Hey folks, welcome to the next video. It's now high time that we move away from all the boring theory and do something more practical and fun. In this video, we are going to set up our first actual game window ready for OpenGL to use. We'll also create a very basic main application loop, which will be filled with exciting stuff later on. Stay tuned. Cool, okay, so in order to use Sdl and OpenGL, we need to include the relevant header files. So we have already included sdl.h over here. Now OpenGL doesn't really, well, the core OpenGL does have header files. I'll get to all of that in just a while. But for now, let's just focus on Sdl. Sdl has the header file, which we have already included, so we can go ahead and start writing Sdl specific code. Okay, so we want to initialize Sdl, and we can do that by calling the Sdl_init function. To do that, we do Sdl init, and it takes in an argument, and we can do Sdl init, just go everything. Okay. This function can be passed various arguments based on what Sdl components you want to set up. In this case, we want to set up absolutely everything, but you can also just choose to set up audio or video or certain parts only. Remember, Sdl is an API and an SDK for developing basically 2D games, so there's a lot that it can do as well. So you can set up basic components for that. But for our intents and purposes, we only want to use Sdl to manage the input and to manage our OpenGL context in our window, nothing further. To keep things easy, I'm just going to go ahead and initialize everything. What this function will return is an int value based on if it succeeded or failed. So a return value of 0 means it succeeded and -1 means it failed. Therefore, we could initialize Sdl and check if all went well in one block of code. So we could put all of this into one statement. So we could say if Sdl init Sdl everything equals to -1. In that case, something went wrong. So we could do a nice little error message here saying error initializing Sdl. Now Sdl runs on pretty much everything, including a toaster. Just kidding. But if you ever get to this error message here, it's likely that you have a very outdated machine. So like I say, Sdl should run on everything, so there shouldn't be an error at all. Great, okay. We'll also declare two variables we're going to need to create an Sdl window where we're going to render within and a OpenGL context. So the window will be Sdl Window, and this is a pointer, and we'll just call this window. And let's actually nullify that as well. So we start with clean, fresh slate. And then we're going to have Sdl Gl Context. Okay, this is actually a pointer underneath, so we don't have to do that, but we're going to nullify this as well. Okay, so these are the two main pointers we're going to need. One that has a handle on the actual application or game window, and the other one's a handle on the context or canvas or environment within which OpenGL will render. Okay, next we want to set a few buffer bit sizes. Now OpenGL and Sdl work really well together, and individual attributes can be set using the Sdl Gl set attribute routine. So that looks something like this. So Sdl_gl and then set attribute routine, and what this usually takes in is the attribute that we want to change and then the value. Obviously those aren't the arguments we're going to pass, but that is the parameters it is expecting. So what we're going to do is set the buffer bit sizes. Okay, so we're going to set the different components. So as you know, for your frame buffer you have your pixels, and for every pixel you have RGB or red, green, blue and alpha channels, and we're going to set every channel bit size of 8 bits. So to do that, we're going to say Sdl Gl red size, and the value would be 8. And we're just going to do red, green, blue, alpha. By the way, if you don't know how to do that, you just put your mouse cursor where you want to duplicate and just hit Control D, and that will duplicate, so you don't have to rewrite this the laborious way. So green will also be 8, blue will also be 8, the blue size The alpha size will also be 8. And lastly, what we want to do is the buffer. All of that put together will be 32 bits or 4 bytes in size. Another attribute that needs to be set is the option to add double buffering. And this is done as follows. Let's just set that to Sdl Gl and its double buffer, just like that. And 1 being true, 0 being false, we want to switch it on, so 1. This will ensure that when rendering to the screen, 2 frame buffers are used, one that displays the actual image and another that is rendered to behind the scenes. Right, the next attribute that needs setting is the OpenGL Context, which we wish to use. This can be set to either a core or compatibility context. I will explain more about core and compatibility versions later on, but for now let's just set that up. So let's duplicate that, and this one's going to be, and this is a really long one, so apologies, Sdl Gl Context Profile. In fact, you can find it mask. There we go. Okay, and we're going to set that to Sdl Gl Context Profile and core. You got core and compatibility. Let's set that to core mode. I'm just going to first write these out, and then I'll explain compatibility. So we can only have one or the other. We cannot have both. Okay. Again, I will explain more what core and compatibility modes mean. But for now, let's just leave it in compatibility mode. Later on, we'll come back to switching between the two. Next, we'll want to set the OpenGL version that we wish to use within this context. Let's set it to a version of 4.0. So again, let's duplicate that. What we'll do is, this is Sdl Gl Context and major version. So if we want to set to 4.0, major would be 4 and minor would be 0. I'm just setting it to 4.0. I think to be absolutely safe so that everybody has it running, I would say 3.3. Okay. More on that later. If you have a pretty modern graphics card, you could go ahead and go to 4.6, which is the latest version. Or if that doesn't work, 4.5. Okay. I'd say pretty much most modern graphics cards today will support 4.5 or 4.6. But again, if you want to be safe, just hit 3.3 or 3.0. Okay, but more on this in a bit. Okay, so I'm just going to set it back to 4.0. Just in a nutshell, setting a core context will not allow any legacy OpenGL code to run and may produce errors. But again, I'll explain this a bit more in detail later. Okay, so now we can go ahead and create our game window, and we're going to use the Sdl create window function. So Sdl create window, there we go. Right, so a few arguments that it needs. First of all, the title. So if it's in windowed mode, if you want to give it a title, we can just give it a really boring name like graphics engine. The next will be the X and Y position of the window, where you want it to be positioned. I'm just going to say put in a standard Sdl window pos undefined, so that places it wherever in X, and the same in Y. Okay, you could also say window pos centered if you wanted to. That puts it in the middle of the screen. I'm just going to put it there. Then it wants the resolution, width and height of the screen. I'm going to go with just a standard HD of 1280 by 720 resolution. And it needs to be, so there's different flags for your window. I'm going to set it to Sdl Window OpenGL to make sure that this is an OpenGL window specifically for OpenGL rendering. Now, I'm not a fan of code spanning out long lengths across the screen, so if you have a lot of arguments like this, I generally just break it up nicely to a bit more readable form. Okay, if you want to put every argument on a separate line, you can do so as well, but this is a lot better than having it run off into the ether all the way to the right. This function will return a pointer to the newly created window or a handle to that window, or it returns null if it failed to create one. So what we want to do is take our window pointer and assign it to this function here. Okay, so that whatever that creates will get stored here. Now through window we have a handle on that window and can use that handle to do whatever we want with that application window. Now there's many different window flag values. If you just go to the Sdl Wiki, you can check out all the different flags you can use. We're going to be using Sdl Window, OpenGL, okay, but you can also have a full screen flag if you want full screen desktop. You can have borderless, resizable windows. There's a whole bunch. So just head over to the Sdl Wiki to find out more. Now, if this returned null, then obviously the window pointer will be null. So we could then say, well, if window equals to null pointer, null pointer, then in that case we could output error messages saying error window, like so, okay. Or slightly more advanced programmers and those who don't like coding too much, you can just say if not window, okay. So if it's null, not null, then obviously something went wrong. Okay, so now we can use the newly created window handle, and we use that to create the OpenGL context. Again, the OpenGL context is the environment, or like the canvas we're going to be using to draw in. So just like a painter has a canvas to draw on, that's the same thing. We need an OpenGL context to draw within. So to do that, we call Sdl Gl create context, and we just pass in the window handle. This is going to return a handle on the window, so we're going to store that in our context pointer, like that. Okay, and again, if that context is null, something went wrong, so we can just copy that, but it's not window, it'll be if not context, and then we can say error creating OpenGL context. If this is more likely to happen, this is probably because graphics drivers are out of date or don't support the current version of OpenGL that you are trying to set up in. So in this case, you could put something a bit more detailed, like go get a better graphics card or update your drivers or something like that. But generally, if you hit this error here, it means there's something, most likely that your graphics card is struggling to set it up in that version. Again, stay on the safe side. 4.0 should be pretty safe, or 3.3, and it should be all okay. Right, when all is said and done, we're done with the application. It's always a good idea to close everything down, close down our systems that we initialized before. So we're going to use the routines Sdl Gl Delete Context. So delete the context we just created, destroy the window, and Sdl quit. What these functions do is free the OpenGL context from memory, destroy the game or application window we just created, and close everything down. Basically do the opposite of what we just did here. Okay, so let's pretend our main application or game loop will go here. So we'll just put some stuff here. By the way, to do that, what I just did now, just hold Alt and your arrow keys, and that just moves stuff up and down. So that's a pretty cool thing as well, if you didn't know. Okay, so our main loop will go there. So let's pretend we are out of our main loop and we wish to shut everything down. And the first thing we're going to do is Sdl Gl Delete Context, and we just pass in the context we created. And Sdl Gl destroy window. There we go. Sorry, just Sdl destroy window. That kills off the window, and then Sdl quit, which closes the entire Sdl down. Okay, so these are all your shutdown tasks here. Okay, this will be your main loop. We'll get to that in a second. This is all your initialization that we've done here. Okay, right, Control S, and let's build this. And that builds nicely. If we run that, we should have, you could see a window just kind of flashed there and then disappeared. Good. So it did create the window, but immediately we then went and destroyed it again. So not much use there. So what we need to do is add a loop that will keep running, and when we're done, we then exit, and the window will then, and the context will then be destroyed. So let's do that next. Okay, so we'll get a small simple application loop running, which will ideally do the following. We're going to clear the screen. We want to render something in there and then swap the frame buffers. So basically, if we think of a loop, first thing about a loop is it loops, it keeps repeating commands until otherwise specified. So let's pretend we have our curly braces here. So we're going to have some kind of condition while app is running is true, or while player has not yet died or whatever, continue running. So the first thing we want to do is we are going to be clearing our screen. So we have to clear our frame buffer, refresh it, and then we're going to do all kinds of things like update our game objects, for instance, or let's say you had some physics built in, you'd update that, or update your input management, poll events off the queue, all kinds of things with update. And then lastly, we actually render all our objects to the screen. Okay, and then we do a swap buffer. So if double buffering is on, then swap buffer will render the next frame. And then this is going to keep looping and iterating all around and around and around until we then state otherwise, whatever that condition is. Okay, so let's set up a condition for our loop. I'm going to go here, and just above here, I'm just going to create a bool flag. Is app running? And I'm going to say true. By default, it is running. Okay, and here's our main loop here. So we'll just do while is app running. Do whatever we got to do. Okay. So again, the first thing we want to do is clear our screen. So all data we see on our game screen lives in a part of memory called the frame buffer. This portion of memory stores all the pixel values that will be drawn and can also be called the color buffer. Every pixel will be stored using a certain bit value, which we set above. And in our case, we set it up to 32-bit color. So each pixel has 32 bits of storage, 8 bits for the RGBA components. For each frame, we have to clear the frame buffer so that the next iteration of data can be loaded in. And to do that, we use the GL clear function. Okay, so that's really simple. GL clear, here's your very first OpenGL command. Don't know why it's spacing out. That's better. GL clear, and it's GL token is GL color buffer and then bits. Cool, okay. And the reason that is creeping up with errors is because we also need to include OpenGL, and that's basically just in a folder called gl.h. Also, what we need to include is windows.h, so let's actually move this up. That needs to be included first. Let's do windows.h there. Okay, and now we should have that all nicely running, and it goes yellow. Good. All right, if we build that, we could possibly have linker errors. Okay, so let's just quickly go into our project properties again. Right click project, go into properties, go to our linker, go to input, just make sure it's on all configurations. Just go in here, and then we need to just include OpenGL 32.lib. Click OK. OK. And build that again. And everything should be fine. If we run that, we should have a window now that is completely white. That's good. It's not swapping any buffers just yet, but at least we have something working. Okay, so just a quick note. Like I said earlier, OpenGL has a very basic gl.h header file. This comes packaged with Windows. All right, so basically it's installed when you install Visual Studio. All this provides is headers for very old OpenGL. Okay, I'll get into more detail about that later on. But for now, we are going to be using just these very simple GL commands just to clear the frame buffer. And for that, I need the GL header file. And for that to compile properly, I need to include windows.h before. So make sure it's included in that order, and preferably all right at the top. Do these first. Because GL clear is an actual function, the linker will be requesting where that function actually is. hence why I had to go into the project properties and just make sure that OpenGL32.lib is being linked correctly. Now again, when we get into extensions later on, I'll explain how we can extend OpenGL so we don't have to do this laborious method of linking OpenGL. Great, okay, so that will clear the frame buffer. Then we'll pretend that we're going to update and render stuff here later on, okay? And then we want to go ahead and swap the buffer. So that's Sdl Gl swap buffer, or sorry, swap window. I keep getting confused. And pass in the window pointer. So Sdl Gl swap window. Okay, so again, the back and front buffers need to be swapped, and this is because we have double buffering switched on, so we actually allowing that to happen. And what this routine does, takes in the game window pointer as an argument and then swaps the frame buffer accordingly. So again, just a quick run, or build and run, whichever you choose, and we should now have a window, a black screen, and this is good. Obviously we're not rendering anything in here just yet, but this is good. This is a good starting point. You can't, as you click on the window and try to quit out the window, you'll see nothing is actually reacting. That's fine because we're not reacting to any inputs just yet, hence why this feels like it's frozen. But the only way to break out is just to either click the console terminal window, close that, or you can just click the red stop button in Visual Studio. That should bring you back into the IDE. Okay, so we have everything set up, ready to render great things, and in the next video we will render our first shape. Before ending off, some final thoughts regarding the Sdl library. If you're ever stuck with any specific Sdl function calls or need a reference list of all API routines, please refer to this website, so wiki.libsdl.org. This is the Sdl2 Wiki, and there's a whole bunch of information here, some tutorials, and just whole reference list that can help you further if you want to delve into Sdl. Now remember, we're only using Sdl to manage our OpenGL context and inputs, and we're just using it as a helper for OpenGL. So if you were using Sdl natively to make games, then this would serve you, then this wiki would be quite helpful. But for now, you know, for the little things that we use Sdl for, this wiki can still be equally helpful, but you don't have to go through this entire wiki to understand what we're going to be doing in this course. Right then, exciting times lie ahead, so see you in the next video.